Grade 10, Gauteng, Paper 1, June 2022. So for question 1, it's an algebra question, and for 1.1 we're given this expression for a, that a is equal to 1 over the square root of 3 plus x, and we're told that x can take on these values here, 0, 1, 2, or 3. And we're asked for which values of x will the expression a be rational. So for our rational numbers, we want a number that can be written in decimal form, that doesn't have the decimal going on forever and ever and ever without a definite pattern to it. And since I know that the x plus the 3 part is being square rooted, I know that for my number to be rational, I want the number under the square root sign to be a perfect square. And then 1 over that number is also going to be a rational number. So out of my values that I'm given here for x, if I add 0 to 3, I'm going to have the square root of 3, that's not a perfect square, it's going to be irrational. When I add 1, I get the square root of 4, which is 2, and then 1 over 2 is definitely going to be rational, so 1. And we can check the other ones, so if x is equal to 2, I'm going to have the square root of 5, which is irrational, and 1 over that number is certainly going to be irrational, and the same with x equals 3. The square root of 6 is irrational, and so 1 over that number will be irrational. So the only value of x that satisfies this expression for a being rational is going to be when x is equal to 1. Okay, then for 1.2, we're asked to factorize the following expressions fully. So for this first one, 1.2.1, we're given 2x squared minus 32. And the first thing that I recognize is that 2 is a common factor in both of these terms. So I can take out that common 2. And in my bracket, for the first term, I'm left with x squared. And for the second term, I'm left with 16. And I can go further because I recognize that in this bracket, I've got my first term, that's a perfect square. My last term is a perfect square, and they are separated by a negative sign. So I know that I can do the difference of 2 squares. So I've still got the 2 on the outside. My 1 bracket is going to become 2 brackets. And the first term in both of the brackets is going to be the square root of the first term in the original bracket. So for each one, the first term is going to be x. And then for my second term in both of the brackets, I'm going to have the square root of the second term from the original expression. So for both of them, it's going to be 4. And then in one of my brackets, I'll have positive, and in the other brackets, I'll have a negative sign. And now I can't go any further, so this is fully factorized. Then for the next one, 1.2.2, I'm given 6a squared minus b plus a 2 minus 3b. So I'm asked to factorize, but I can see that in this expression, I don't have any common factors within the terms at the moment as it stands that I can factorize. So what I'm going to start by doing is distribute this a into this bracket. So my first 2 terms are going to stay the same. And then I distribute the a, so for the first term I have 2a, and for the second term I have minus 3ab. Okay, and now I'm thinking that I can use grouping to factorize these things, and I can see that this term has got a b and this term has got a b, so I know that these two must be grouped together, which means that I'm going to group these two together. So I'm going to first rearrange my expression to have the things I'm grouping next to each other. So I'm going to bring this 2a by the 6a squared, and then I've got minus b and minus 3ab. So I can see that with these two terms, if I take out a common negative b, I'm going to be left with 1 at the front here and a positive 3a in the second term. And I recognize that I can take out a 2a in these two terms, and I'm going to get a bracket that looks the same as when I take out the common negative b in these two terms. Right, so for the first one, I'm going to take the first 2 terms, I'm taking out a common 2a, and I'm left with 3a in the first term and 1 in the second term. And now for these last 2 terms, I'm going to take out a common negative b, And for the first term, I'm left with 1. And for the second term, I now have a positive 3a. And I can see that this bracket and this bracket are exactly the same. So from this one term and from this other term, I'm going to take out a common bracket 3a plus 1. So I take out 3a plus 1. And for the first term, I'm left with 2a. And for the second term, I'm left with negative b. That's this and this. And that is fully factorized. And if you want to check that you've done it correctly, you can go back and distribute these two brackets. So multiplying each term in the first bracket by each term in the last bracket, and check that you get back to your original expression, either this one or this one. So we can do that by FOIL. Okay, and FOIL says I multiply the first two terms in the brackets, so it's going to be 3a times 2a is 6a squared. Then I'm multiplying the outer terms, so I'm going to have 3a times minus b, which is minus 3ab. Then I'm multiplying the inner terms, which is 1 times 2a. And then I multiply my last terms, 1 times negative b. And I can see that this is exactly what I had as my original expression, so I know that I factorized correctly here. Okay, the next part of question 1 is 1.3, and we're asked to simplify the following. So for this first one, 1.3.1, I have two brackets, x minus 1 and x squared plus x plus 1. So to simplify, I'm just going to multiply every term in this first bracket by every term in the second bracket. So I'm going to have x times all of these, and then I'm going to have minus 1 times all of these. So when I'm multiplying the x first, I have x times x squared, which is x cubed. X times x is x squared, and x times 1 is x. And then when I'm multiplying negative 1 by everything, my first term is going to be negative 1 times x squared, which is minus x squared. Negative 1 times x is minus x. And negative 1 times 1 is negative 1. And now I'm going to group my like terms. So I've got two things with x squared. I've got two things with x as well. And those are my only like terms, and I can see that these terms will cancel each other out. So this positive x squared minus x squared is 0, and this positive x minus x is 0. And so I'm just left with these two terms, x cubed minus 1. For the next part, 1.3.2, we're given some fractions with expressions of x. So since the question is asking us to simplify, that means that I want to end up with one fraction. And to end up with that one fraction, I'm going to have a common denominator between these three so that I can add my numerators together. Right? So I can see that the first one is a quadratic term of x, and the other two are just linear terms of x. So I know straight away that I'm going to want to turn this quadratic factor into the product of two linear factors of x. So I'm going to factorize this bottom bit, and then the brackets of these two I'm hoping are going to match. One of them is going to match with this one, and one of them is going to match with this one. And then I'm going to be able to get a common denominator. So my first step is going to be to factorize the first fraction's denominator. So I'll still have x plus 7 as the numerator. And when I factorize at the bottom, I get x minus 3 and x plus 2. And if I'm not sure, again, I can do FOIL. So I'll multiply these first two together, I get x squared. Then I multiply the outer ones together, I have plus 2x. And then for the inner ones, I'm going to have minus 3x, and plus 2x minus 3x is minus x. And then for the last ones, I multiply them together and I get minus 6. So I know I factorized correctly. Then I'm going to keep the other two the same, so I still have 3 over x minus 3 and 2 over 2x plus 4. Okay, so now I want to go about getting my common denominator. So I can first see that this bracket matches this bracket, which is what I want. So I know that for this fraction, I just have to multiply the top and the bottom by x plus 2. And now for this one, I want to match this denominator with one of these brackets, and I can see that it's almost the same as this bracket x plus 2, it's just multiplied by a common factor of 2. So I can take out a common 2 from this expression, and what I'll be left with is 2 on the outside and a bracket, and that bracket is going to be x plus 2, which is what I want. Then when I can show that that bracket is x plus 2, I can multiply this fraction by x minus 3 at the top and at the bottom. Okay, so I'm going to take out a common 2 from this bracket, which means that I have 2 and x plus 2. And I see that this 2 can cancel out with this 2 in the numerator. So I'm just left with 1 at the top. Okay, and now I will have my common denominator if I multiply this fraction by x plus 2 over x plus 2. So the bottom and the top is being multiplied by x plus 2. And then I can multiply this fraction by x minus 3 over x minus 3. So I multiply x minus 3 at the top and x minus 3 at the bottom. So in my next line, I'm going to have everything over this common denominator, x minus 3, x plus 2. Okay, for the first fraction, it stays exactly the same, nothing's being multiplied. For the second one, I have minus 3, and that minus 3 was multiplied by x plus 2 to get this denominator to be x minus 3, x plus 2. So I have this. And similarly, the last one, I have 1 being multiplied by this bracket, x minus 3. Okay, and then I can go ahead and simplify the numerator, so my x plus 7 stays the same. I'm distributing that minus 3 into the bracket, so for the first term I'll have minus 3x, and for the second term I have minus 6. And then my last one is just 1 times everything, so the bracket will stay the same. And this is all over my common denominator. Okay, and then I'm grouping my like terms at the top. So for the x's, I will have x, minus 3x is minus 2x, plus another x is minus x. And then for my numbers, I'm going to have 7, minus 6 is minus 1, 7 minus 6 is positive 1, and then minus 3 is negative 2. So in my numerator, from the x's, I have minus x, and from my constants, I have minus 2. And x minus 3, x plus 2, and I'm not done because I can see that my numerator almost looks like this bracket here in the denominator. It's just that we have got negative x here, I've got positive x here, and we have got negative 2 here, I've got positive 2. So to make them look the same, I'm going to take a minus 1 out of this expression, and I'm going to be left with a bracket that looks exactly like this one. So I take out a common minus 1, and in my bracket I now have positive x and positive 2. And this is over the same common denominator. Okay, and then I can cancel out these two brackets. And I have my final answer, negative 1 over x minus 3. Then for the last bit, 1.3.3, I've got a fraction again, but now I've got exponents with x's in the exponents. So I'm given this expression. So to solve this question, I want to use my exponent laws, and I know that my exponent laws, when I want to add and multiply exponents together, I need to have common bases. So I've got at the moment 4 and 9 and 6. These aren't common, so I won't be able to do anything adding and subtracting the exponents. But what I can do is write these numbers in terms of them having common bases. So for 4, instead of writing 4, I'm going to write 2 squared. And that's still going to be raised to the x plus 1. And then for 9, I'm going to write 3 squared. And that is still raised to the x. And then for 6, I'm going to write 2 times 3 raised to the same exponents. And I chose these numbers, the 2 and the 3 and the 2 and the 3, because I want to be able to have the same bases that I can do things with the exponents. Okay, but first I'm going to simplify my exponents. So I know that when I've got an exponent raised to another exponent, I can just multiply the one by the other one. So for this one, I'm going to multiply 2 by x plus 1. And for this one, I'm going to multiply 2 times x. And then here, when I've got 2 bases being multiplied together, and they are both raised to an exponent, I know that the exponent belongs to the one base, and it also belongs to the other base. Okay, so at the top, I'm multiplying the exponents, and I'm going to have 2 to the power of 2x plus 2. And then for this one, I'm just going to have 2 times x. And then at the bottom, I'm going to separate these bases, so I have 2, which has 2x minus 1, multiplied by 3, which is also raised by 2x minus 1. Okay, and then I know that when I have an exponent that is an expression of x, so like this 2x plus 2, and I have a base 2, then that's the same as having this base 2 to the power of the first term of the expression of x multiplied by the same base 2 to the power of the second term of this expression. So that means that 2 to the power of 2x plus 2 is the same. 2 to the power of 2x plus 2 is the same as 2 to the power of 2x multiplied by 2 to the power of 2. And that's going to be the same for these two. So I'm going to have 2 to the power of 2x multiplied by 2 to the power of negative 1. And here I'll have 3 to the power of 2x multiplied by 3 to the power of negative 1. Okay, so for this one, I'm separating it out. And that's still multiplied by 3 to the 2x. And I separate this one as well. And I separate this one. And then I see I've got two numbers that are raised to a negative exponent, and all that tells me is that I'm going to bring these numbers from the denominator to the numerator, and the exponent is now going to be the positive version of whatever it was before. So I can move this 2 to the top, and instead of being raised to a negative 1, it's now going to be raised to a positive 1. And the same with this 3, I'm going to move it to the top, and it's going to be raised to positive 1 instead of negative 1. And I move this 2 up. Then I had 3 to the 2x, and I'm moving the 3 up, positive 1, and the rest of the denominator stays the same. Okay, and now that I've got all like bases, so I've got some things that are to the base 2, some base 2's, and I've got some base 3's, I can use my exponent laws to add or subtract the exponents. So for all of the base 2's, The ones that are in the numerator, which is these three, I'm going to add all the exponents together, and then the one that's in the denominator is going to have a negative exponent. So for my base 2, I've got a positive 2x plus a 2 plus a 1, and then this one at the bottom is going to be negative, so I'll have minus 2x. And with the base 3's, I've got a positive 2x in the numerator plus 1, and then I've got this one that's in the denominator, so this exponent is going to be negative, and that's minus 2x. Okay, and then I'm grouping the like terms in the exponents. So for the base 2 one, I know I have a positive 2x and a negative 2x, which is going to cancel each other out. And I'm just left with 2 to the power of 1 plus 2, which is 3. And then for the base 3 ones, I've still got this negative 2x and positive 2x, which are going to cancel each other out. And so I'm just left with 3 to the power of 1. And 2 to the 3 is 8, 3 to the 1 is 3, and this is 24. And then the final part of question 1 is 1.4, and we're given the following information, that x is an even integer and x is greater than 1. And we're asked to arrange the following in ascending order, so we're arranging these from smallest to biggest. So we're going to compare all of them. So for the first two, we've got minus 2 to the power of x and 2 to the power of x. So if I just look at 2 being to the power of x, like I have for both, it's going to be the exact same number, but this one is going to be the negative version of whatever that number is. So I know for sure that this one is going to be smaller than this one. Okay. Then we can compare the next number. So this is 2 to the minus x, and that means that I'm going to have, if my x has got a negative exponent, then this has got to be in the denominator, so I'll have 1 over 2 to the power of x. And this 2 to the power of x is going to be the same number as this 2 to the power of x and this 2 to the power of x, but now I've got it as a fraction. So this is 1 over this same number, which means that this is certainly smaller than this one, but it's not smaller than this one because it's still positive. Okay, so for the third number, I know that it's bigger than the negative 1. It's bigger than that one, but it's going to be smaller than this one. So it's in between these two. So now we know this. And then for the next one, we've got 2 raised to the x, which is raised to the 0. And I know that everything raised to the 0 is 1. So this is equal to 2 to the 1, which is 2. And remember that in the question I was told that x is greater than 1. So this 2 that's raised to the 1 is going to be smaller than whatever this x is, because this is raised to an integer that is greater than 1. So this could be raised to 2, 3, 4, so on and so on and so on. But any number that it's raised to is still going to be greater than 2 being raised to the 1. Right, so I know that this is going to be smaller than this one, but it's still going to be bigger than this one because this is the fraction. So I know that 2 to the x to the 0 comes here, and then this one was the 2 to the x. And then for the last one, we have 2 to the x raised to the 2. So whatever this number is here that's raised to x, this one is certainly going to be bigger because I'm still got 2 raised to the x, but this one is x squared. So if this is 2 to the power of 2, then this one is going to be 2 to the power of 4, certainly bigger. And for any integer greater than 1, it's going to be true that this number is greater than this number. So we have this. And of course, if this one is greater than this one, then it's greater than all the rest. And that's the order. Then for question 2, the first part 2.1, we're asked to solve for x. So for 2.1.1, we're given the square root of a times x is equal to b. So I'm solving for x. I want to get x on its own. The first thing I'm going to do is square both sides to get rid of this square root sign here. So I square this side and I'm just left with what was under the square root sign. And then when I square this side, I just have b squared. And now I want to get x on its own, so I need to divide by a on this left-hand side, but this is an equation. Then again, I want to get x on its own, so to get it on its own on the left-hand side, I've got to divide the left-hand side by a, and as I've got an equation, I need to do everything on the left-hand side as I do on the right-hand side. So on this side, I'm also dividing by a, and on the left-hand side, I'm just left with x. And here I have b squared over a. Okay, then 2.1.2, I have 3 to the x plus 3 to the x minus 1 is equal to 36. Okay, so I've got two terms here that have a common factor of 3 to the x. Okay, so using my exponent laws again, I see that I've got this 3 is raised to an expression of x, so I've got an x minus 1, which means that I have 3 to the power of x multiplied by 3 to the power of negative 1. Right, and then on the left-hand side, now I can see that I've got two terms, this one, and they've got a common factor of 3 to the power of x. So I can take out a common factor of 3 to the power of x, and I'm left with a bracket. So I take out 3 to the power of x. For the first term in the bracket, I'm left with 1, and the second term, I'm left with 3 to the minus 1, which is equal to 36. And this I know to be 1 over 3, because it's going to be 1 over, and then my exponent becomes positive, so 1 over 3 to the power of 1, which is 1 over 3. And I add 1, so I get 4 over 3. Now this is the only thing that has x in it, so I want to isolate this on the left-hand side. So I want to get rid of 4 over 3 on this left-hand side, and I can see that it's being multiplied here, so to get rid of it, I can divide it. So I'm dividing the left-hand side by 4 over 3, and I'm dividing the right-hand side by 4 over 3. And to divide 36 by 4 over 3 is the same as multiplying by 3 over 4. So on the left-hand side, I'm left with 3 to the power of x. And then on this side, I've got 36 divided by 4 over 3, which is the same as multiplying by 3 over 4. And that's 27. Okay, so now I've got 3 to the power of x equals 27. And I can write 27 as 3 cubed. So now I have 3 to the power of x equal to 3 cubed, which means that x must be equal to 3. In the next part, 2.2, I'm given this inequality. For the first part, 2.2.1, I'm asked to solve for x. Okay, so the first thing that I see is that I've got fractions, and I want to get rid of the fractions. So on this left-hand side, I've got x being divided by 3, so I can multiply everything by 3 to get rid of the divide by 3 on the left-hand side. So when I multiply by 3 on this side, I'm going to be left with just x. And then on this side, I'm going to have 3 multiplying the first term, so I have 3x over 2, and then I've got 3 multiplying the 1, so I'm going to have 3. So this is my original expression. I multiply everything by 3, I'm left with x on the left-hand side, 3x over 2 plus 3. on the right hand side. And then I've still got a fraction with denominator 2 on the side, so now I'm going to multiply everything by 2. So on the left hand side I'm going to have 2x. For this term I'm just going to have 3x, because when I multiply by 2 they're going to cancel out and I'm just left with the numerator. And then the 3 is also going to be multiplied by 2, which is 6. Okay, now I want all my x's on one side and all my numbers on the other side. So I'm going to take 3x over to the left-hand side and I'm left with minus x and 6 on the right-hand side. And I was asked to solve for x and not solve for negative x, so I want to multiply both sides by negative 1 so that I have x on the left-hand side and I have negative 6 on the right-hand side. But when I multiply an inequality or divide an inequality by a negative number, I know that my inequality sign has to change direction. So instead of having the greater than, I'm now going to have a less than. And I've multiplied everything by negative 1. So on the left hand side I've got x, and on this side I've got negative 6. Then for 2.2.2, I'm told that x is an integer, and we're asked to write down the first 2-digit number that satisfies the inequality. So my x has to be an integer and it has to be less than negative 6, which is what we found out. So the first number less than negative 6 that's an integer is negative 7, and then it's negative 8, negative 9, negative 10, and that's a 2-digit number. So the first one is x equals negative 10. And then for the last part of 2.3, then for the last part of question 2, 2.3, I'm asked to solve for x and y simultaneously. So I've got two expressions of x and y, and I'm going to call them equation 1 and equation 2. Okay, so there's two ways that I can solve for x and y simultaneously. The first, I'm just going to add the two equations together. So I'm going to say 1 plus 2. Right, so I'm going to add the x's together and I get 5x. I add the y's together and I get 0. And then I have my equal sign. And then I add the 4 and the 11 together and I get 15. So 5x equals 15, then x must be equal to 3. So I found x, and then I can substitute this value of x equals 3 into either this equation or to that equation to find the value of y. Okay, so I'll do both. So sub x equals 3 into equation 1. So everywhere that I see an x in equation 1, I'm not going to write x, I'm going to write 3. So I'll have 2 times x is equal to 3 plus y equals 4. Okay, this is 6, so I can take the 6 over to the other side and it becomes a negative 6. 4 minus 6 is minus 2. So I'll have that y is equal to minus 2. And just to check that I've done it correctly, I'm also going to substitute x equals 3 into equation 2. And so everywhere that I see x, I'm not going to write x, I'm going to write 3. So 3 times 3 minus y equals 11. 3 times 3 is 9. I take it over to the other side, it becomes negative 9. So I have that y is equal to positive 2, 11 minus 2. And I want y, not negative y, so y is equal to negative 2, which is the exact same answer I got here as expected. So I've solved for x and y simultaneously. I have x equals to 3 and y is equal to minus 2. Then the second way I can solve for them simultaneously is that I'm going to write y as an expression for x, And then, so I choose one equation. Let's say I choose this equation 1. I'm going to take the x to the other side, and then I'll have y is equal to 4 minus 2x. So I've now got y written as an expression of x, and then I'm going to substitute that expression of x into the y of the second equation, and then I'll only have x's in the second equation, and then I can solve for x. Then I take that x and I go back to one of the original equations, substitute it in, and I find my value for y. So I'm going to take equation 1 and I'm going to rearrange it to be y equals something with x in it. So I had the 4, and then I'm taking the positive 2x to the other side. It becomes negative 2x. Now I've got an expression for y in terms of x, so I'm going to substitute this into equation 2 now. So everywhere in equation 2 that I see a y, I'm not going to write y, I'm going to write 4 minus 2x. So the 3x stays the same. Then I've got negative y equals 11, and I just simplify. So x equals 3. Then I take this x equals 3 and I can substitute it into either one of the original equations like I did before. And from the other way that we did it, we can see that when we subbed x equals 3 into equation 1, we got y equals negative 2. And when we subbed x equals 3 into equation 2, we get y equals negative 2. So I'm just going to copy this, it's the exact same. And that's the second way we've solved for x and y simultaneously.